So the final exam is next Thursday. What would that date be? The 22nd? Maybe someone could just check that. Okay. You can also write with my other class on June 21st if you want to. Same room, same time. Okay, so I have two classes, so I'll bring both tests to both times, and you can choose either. If you want to get it over with Wednesday, then you can do it Wednesday instead. Okay? Oh yeah, sorry. So just your choice. Okay, so show up to one of them. The Math Learning Center, they are open from Monday to Thursday from 5 p.m. to 9 p.m. There's two different tutors. Alex is there on Tuesday and Thursdays, and then Doyan is there on Monday and Wednesdays. Okay, they can both help with the course, but if you wanted Alex in particular, he's there on Monday, Wednesday night. Okay, and that's just free math help, so you could actually go there and study if you wanted to. You don't have to have questions. All right, so what we're going to do is the handout I gave you. So there's 3 sheets. We're just going to solve this. The exam is very similar to this review. Okay, just a few less questions. And I'm giving you 2 hours to do the final exam. It's a 3-hour period. If you want to stay longer, you can, but it's meant to be 2 hours. Okay, I'm just going to start marking at 9. Hopefully some of you will have passed them in, and you could stay longer if you need to check. But it's meant to be just a 2-hour exam, not 3. Okay, so I wrote it smaller. So it's about this length. It has these topics on it. So if you just look through this sheet, we've got some logs and exponentials to solve. Then a piecewise function and continuity. So you could be asked a question like this. Integrals, which is what we just did. The last test on limits. I have a whole bunch of limits there. Then solve the initial value problem. So that is integrals again, but when you solve for C. The absolute extrema, which means max and min, right? We talked about those on an interval. So we'll do some of those questions, and then a few word problems. Okay. So for extra practice, just the same as doing your test, you've got your test, but you also have all the homework that was, if you can do everything, then the final will be no problem. And I believe the final is 40%? Yeah. Okay, so we're just going to go through this sheet and solve these problems. So to start, okay, so I'll write the question down. And we'll just do the answer in a different color, so if you look back, you can see. All right, so how do we solve an expression like this? So the x is up in the exponent. We need to have the x not in the exponent. So how do we get rid of the e in front? Yeah, and you don't multiply by ln, you take the ln of both sides. So we take the ln of both sides. That makes these cancel out. And we've got 2x plus 1 is equal to ln 3. And then just solve for x. So we would subtract 1 and then divide by 2. Now be careful you don't subtract 1 from the 3, because the ln 3 is a number. And then from that number we're subtracting 1 and then dividing by 2. Okay, so let's get our answer. Everyone have their calculator? So we should get for this 0.4931. We'll put, oh, that was wrong actually. 0.0493. There we go. Okay, number 2. So, same idea, but if you recognize that the base are the same, or we can write the bases as the same, both as a base 2, how can we write 4 as a base 2? 2 squared, right? 2 to the second power. So what we would do is write that as 2 squared. Now the bases are the same. You can ignore them, because if the base is the same, then the exponent has to be the same. And then just solve for x. Okay. So that's the 2 types of exponentials. Either you can't make the base the same, like this first one, and you have to take the ln of both sides, or the log, or they do match up, and then you write it that way and cancel out the base. Number 3. Log base 3 of x equals -4. So there's a couple ways we can do this, but the inverse relationship is what? Yeah, so if we have, they'll just write it as a little definition here. A, this is the base, a to the power b equals x. So that's how you would rewrite it, and then you can solve that equation just like we were doing in question 1 and 2. So if we were to rewrite this one, this would be 3 to the power -4 is equal to x. So x is 3 to the -4, which is 1 over 3 to the 4, or 1 over 81. Right? Just when we wrote it, it was already the answer. 3 to the -4. There wasn't anything to do. Questions? Okay, number 4. Same idea? So how could we rewrite this? If we did the same thing, 9 to the power 1 is equal to that. 9 to the power 1 is equal to -2x plus 13. So 9 to the power 1 is just 9. So 9. And so x is 2. Okay, this one looks maybe a bit trickier. It's got an 81 to the x, but you can do the exact same thing. Or you can take this, you can also do it the way I do it myself usually, is to raise both sides to the power of whatever you want to cancel. You could do it that way as well. So this would be 81x equals 3 cubed. The other way is just to use that inverse relationship. It'll give you the exact same thing. 3 to the power 3 is equal to 81 to the x. So we've got that either way. Okay, what I was doing in class probably was putting a 3 on both sides and canceling. That gives you the same thing. All right, how do we solve this? Right. 81 is a power of 3. So what about that x? It's still up as an exponent, so it would go like that. So, right, 81 to the x is 3 to the 4 to the x, and then you multiply the exponents. So basically just leave, if there's already an exponent, you leave it there. They get multiplied. So now the base is the same, so we can just compare the exponents. 3 over 4. Okay, number 6, the last one. Log 1,000 equals x. It's already solved for x, we just need the answer. Right, it already says x equals, but I just wanted to put this one down. What's a log without a base? 10. So that's understood to be a log base 10. So this is log base 10 of 10 cubed. They cancel, and what's the answer? Just 3. Now you could do the same thing. 10 to the x is equal to 1,000. So 10 to the x equals 10 to the 3, so x equals 3. So 2 ways to do them. If these are touching and they already match, you can cancel them out. You don't need to go through the inverse. But you can always do it that way if you want to. Okay, so that's that type of question. So there'll be a few of those. Those could also appear in a word problem if the word problem had like an E or a lon in it and you had to plug a number in. Right, so those techniques of doing that could be used here or in a word problem where you have to, solve for, plug in the y and solve for x, or plug in the x and solve for y. Okay? But if you practice those, that should be no problem. Okay, piecewise function. So let's just write it down. Okay, so the question says, A says, using the formal definition of continuity, limits, and the 3 steps, show that the following function is not continuous at -3. Now, and part B says graph it. I'm going to do it in that order because I want to show you that you don't need the graph to answer the continuity question. So if I don't ask you to graph, what happens is if you think that you have to graph it and then you end up not having to graph, it takes a lot more time to do that if you didn't need to. So we're going to do it without graphing, but then I'll graph it to show you. Okay, so they're asking for the continuity at -3. So at -3, so the 3 steps are these. You plug in -3, f of -3, and that's step 1. Step 2 is the limit as x approaches -3 from the left, and the limit as x approaches -3 from the right. You do these 3 things, and if they're all equal, it's continuous, and if any of them are not equal, then it's not continuous. So that's sort of the form. As soon as you see that you are asked about it being continuous or not, you write those 3 things down and you solve them. Now how do we solve this first one? So that says f of -3. So you look up at your function and you're looking for where the equal sign is on the -3. So these 2 pieces have the -3. This is when x is, here's -3. So the first piece, 2x plus 1, is when x is lower than -3. And this piece, x squared plus 2, is when x is bigger than -3. This is the left-hand side, and this is the right-hand side. Which one is on the equals? The x squared plus 2 has the equal sign, so that's what you would plug it in for the function. So x squared plus 2 is 11. Now for the limits, you rewrite the limit, and you, instead of f of x, you actually put which piece it is in there. So on the left-hand side, we said the piece is, on the lower side is 2x plus 1. And then to solve the limit, you just plug the number in. That negative sign after just means the side. It's not, doesn't mean it's negative or something. So already we can see it's not continuous because this and this are not equal. And you would do the limit on the other side, and that would be x squared plus 2. So you'd say, okay, well these are not equal, therefore f of x is not continuous at x equals minus 3. So that's what we'd be looking for if it said to use the definition. So even though you get to the second one and you know already it's not going to work, you carry through with the 3 steps. Okay? So we could just add in to do it for x equals 0. So what would that look like? F of 0, the limit as x approaches 0 from the left, and the limit as x approaches 0 from the right. So where's the equal sign for the 0? That's on the last piece. So we would plug the 0 in here. Zero plus 2. Which piece is on the left? So now we're looking at these two pieces. On the lower side is x squared plus 2, and on the higher side is minus 3x plus 2. So from the left would be x squared plus 2, plug in the 0, is 2. And on the right, minus 3x plus 2, plug in the 0, and we also get 2. These are equal, and equal, everything's equal, therefore f of x is continuous at x equals 0. So what does that mean on the graph to be continuous or not continuous? So if it's not continuous on the graph, the pieces aren't joined together, and if it is continuous, then they actually attach to each other and you keep going. And Part B asks us to graph that, so we'll just do that. So if we take our piecewise function, whoops. Okay. So when I'm graphing, I usually start with a number line and put the pieces on the number line where they go. So we've got a minus 3 and a 0. So below 3, we have y equals 2x plus 1. Between 3 and 0, we have y equals x squared plus 2. And beyond 0, we have y is minus 3x plus 2. Now for each of them, you need to look at what type of graph they are to get the right information. You always plug this number in as a point. So if you were doing like a table of values to plot these graphs, here you always need the minus 3. Whether there's an equal sign or not, it doesn't matter, because there's not an equal sign here. So what does that look like on the graph when we draw that point? We put it as an empty circle instead of colored in, but it still starts there. It starts at 3 and it goes less, so you need to put it, you still need that point on there. It's just that it's an empty circle. And then this is a line, right? It's a linear equation, so we need one other point. So what would be another x value we could use? Anything less than negative 3 has to be in the right area. So we can't plug in 1 or 0 or anything like that. It has to be a number less than negative 3. Let's say negative 4, negative 5, negative 10, anything like that. to draw a line, you need 2 points, so that would be enough. You could do more if you wanted to, but just a line needs 2 points, where a place to start and one to go to. So if we plug this -3 in, what do we get? 2 times -3 is -6 plus 1, -5. And the 4, -8 plus 1 is -7. Okay, so we have 2 points, -3, -5, that's an open circle. And then -4, -7, which is just part of the line. So this is going to have an open circle and go in that direction. Now what type of graph is this in the middle? It's a parabola because of the x squared. So what do we need to be able to draw a parabola? We need the vertex. So, but because this is a piecewise function, we also need to have the -3 as a point and the 0, both sides, to know where to stop and start it. So we need those two, but we also need the vertex. Do you remember how to find the vertex? Minus b over 2a. That'll give you the x value that you need to plug in. So remember, a quadratic is like this, and ours, a would be what? 1, B, 0, and C, 2. We don't actually need the C for the vertex, just those two. So minus 0 over 2 times 1 is 0. So 0, this will be our vertex. That point. Okay, so plug the numbers in that we need. So if we plug -3 in, we get -3 squared is 9, 9 plus 2 is 11. And here if we plug 0 in, 0 squared plus 2 is 2. So our vertex is 0, 2, and our point is -3, 11. So -3, 11, that would be colored in on this side because of the equal sign. And this side will be open. And it goes in between those with no arrows because it's a parabola in between the two. I'm not drawing that as saying it's a straight line. I'm just saying the line, whatever the curve looks like, joins on the ends like that. A dot on one end and an open circle on the other end, and no arrows because it can't pass through there. And then our last one, we need the 0. And what type of equation is this? It's again the line, so we need one other point, something bigger than 0, so 1. Any number bigger than 0, and plug it in. So 3 times 0 plus 2 is 2, and minus 3 times 1 plus 2 is -1. So we have 2 points, 0, 2, and 1, -1, and this one has an equal sign, so it'll be colored in. So this one will be colored in at the 0, and it goes in that direction. So you have to look at each piece and do your table of values, however it is, whatever you need. In these, we usually just do lines and parabolas. In the real world, they wouldn't have to be just those types of equations, but... Okay, so we want to go down to -3. And 0 is our higher number. We've got a 1 that we plugged in. We've got a -4 that we plugged in. And our y values are what? -5, -7, so we need to go down. I just went down by 2. So start here and very carefully remember what you're doing. The first point was an open circle, -3, -5. And then -4, -7. And it starts at that point and goes in that direction. Right? We said that it started at 3 and went in that direction. So we started at that -3 and go that way, through the other point, of course. You need to label those starting and stopping points. The next one, -3, 11. Oh, positive 11? I didn't go up high enough. So, -3, 11. And this one is colored in. And it's a parabola, but the vertex is at 0, 2, and do we want that colored in or not? So if I put these by this, it would have been easier. Oh, 0, 2, right here. Open. And it's a parabola. We don't even have the whole parabola. We just want it between these two. It doesn't go back up the other side. That's the vertex. It's the lowest point. So you can imagine that the parabola goes normally like this. But we only want the piece of the parabola that's between those 2 points. And here, 0, 2 is now colored in. We have it not colored, so what do? You don't make some fancy dot in the middle or anything. If it's colored in any of them, you color it in, because it's colored for the whole graph. So now that's colored in. And then 1, -1 is down here. That goes in that direction. So this is continuous on this side. They attached. On this side was not continuous. Any questions? So far, so good? How long have we been taping? 27? Okay, perfect. Okay, so we'll stop that.